Now, in our yesterday's session, we completed discussing Docker file instructions and we have seen almost everything that is important. And we discussed about Docker networking. Docker by default uses Docker Bridge. Okay, so whenever you install Docker, so this is created by default generally Docker 0. Okay, but the disadvantage with the Docker Bridge network is you cannot communicate the containers with the names. Okay, so that is why Docker always recommends to create our own network. Yeah, whenever you create your own network, you can mention it. So this Docker containers within the same project can communicate with their names. Okay, so that is the advantage. Docker Bridge network is completely internal to the server within the Docker host only. Nothing to expose to the outside world actually. Okay. And then we started creating our components. Yesterday we faced one error with web components. So the problem was that the names mentioned in the database, okay, while configuring MongoDB, and then in the web static images folder, this is different. Okay, so yesterday I changed it. Now everything is same. The problem was I took this catalog.js from internet. Now I just took from our actual application. Okay, when you are practicing, you take code from this repository. Just copy the code from the repository and then you can create your Docker files and everything. Okay, so yesterday we worked with catalog, MongoDB and web components. Now let us just configure them once again. Okay. Git pull. So Docker images, I don't have any images right now. Now without having any images, can I run Docker command? Can you please answer in the chat? So without having any image, can I run Docker command, Docker run command? I mean our custom images. I don't have any images like web catalog, MongoDB. Can I still run Docker run? Can someone please raise hand who are saying yes, we can run Docker command? If you want to explain, please. Yes, Santosh.
Yeah, yes, Shiva, for you are running from the hub directly downloaded.
Okay. The Docker Hub is like open source images, right?
Yeah,
Yeah. So, but I don't have any images right now related to our RoboShop. I don't have. Can I still run?
still no.
Yeah, right. Thank you. So Docker run is nothing but configuring the image. Configuring image to run as container. So you should have image either local or somewhere in internet like hub. Okay, if you don't have, obviously we cannot run it. Okay, so let me create the images first. So cd web docker build -t web v1 dot. Okay, image is built. Now I can push this image as Santosh said, either image should be in local or image can be in the hub also. Okay, we can download at runtime. Docker run can download, but for that you need to push the image. Okay, now I need to tag this. So you remember last time I said the format is URL slash username slash image name slash colon version. Okay. So URL you don't need to mention if you are using Docker Hub directly. It is by default considered as docker.io, but it is must to provide your username. Otherwise, Docker cannot understand where to push the image, right? It is everything based on the username, just like GitHub. So our GitHub is based on username. You can see whatever the repo name can be same. You can create the same repo name, but URL, how can it be differentiated? It is based on the username. Right? I'm sure many of you are creating the repos with the same name as I'm creating here, but the only difference in the URL is the username. So username is unique. So it is always mandatory to mention the username. So I'm just tagging this. You can say retagging. I'm tagging web colon v1 as join DevOps slash web colon v1. Now you can see image IDs are same, content, everything is same, but the name is different because why I'm giving this name, I can push this image to the Docker Hub. You have to log in, Docker login, give your username and password. Okay, so now you can push Docker images, Docker push, and this is the one colon v1. Okay, now it is pushed. Okay, now you can go and then check the tags. These are the versions available. So anybody can pull Docker pull join DevOps slash web colon v1. You can pull like this. Okay. And then mongo db Docker build hyphen t mongodb colon v1 dot. So this code, right, in our Visual Studio, catalog.js, I got it from our projects only. Our zip builds are there, right? RoboShop builds. I got that from our project. Okay. And then user.js also. So that is done. MongoDB is done. Now catalog. Docker build hyphen t catalog colon user dot. catalog image is also built. Now we need to run the containers. Docker run. So what is the sequence? If I first run directly catalog without MongoDB, so it will get an error, right? Please respond in the chat. So if I run without MongoDB, catalog will get an error because catalog is trying to connect to the MongoDB. So that is why it will get an error. So Docker run -t hyphen name. First I'm running MongoDB. MongoDB. I don't need -p because I'm not exposing this to internet. MongoDB :v1 dot. So yesterday we discussed network also. Before that, mention create Docker network. Docker network create RoboShop. Okay, network is created, and then so now I need to run this MongoDB with the network. Network equal to RoboShop, and then MongoDB :v1. Okay, so MongoDB is run. Similarly, let's run catalog. So you have to attach to the same network. Docker logs catalog. Okay, MongoDB is connected. And then same web also. And here also web. But you need to attach to the port because we are exposing this to outside internet. Now you can open this IP address in the browser. Okay, so everything is done. Right? So now let us configure other components like user. So let me get that user code. This is our user. Open this. Extract. Extracting. So copy this server.js and package.js. Okay. And then, so here DevOps and then purpose RoboShop Docker create user folder and copy this. So this is our code package.json and then server.js, right? And exactly for this same Docker file, create. Okay, so now user, if you see, user is dependent on Redis, right? You can see user is dependent on MongoDB and MongoDB is running. There is no problem. And we loaded the user data also, but it is dependent on Redis also. Okay. Redis, we are not doing anything much. Actually, we are just installing it. If you see, we are just installing it. That's it. So it is fine. What you can do here is Docker run Redis -d. So you should have Redis container running, but it should be attached with hyphen network equal to RoboShop. Okay, we are not doing anything with Redis, just like MongoDB. So what are we doing here with MongoDB? We are just adding one extra step, that is loading the data. But Redis, we are not loading any data. Okay, so we are just running this. Okay, you can just run directly in the detached mode. Redis name and network is RoboShop, Redis image. That's it. So this will create the container. Docker PS. You can see Redis is running. It opened by default 637. So now user can directly talk with it, because inside user, you can see our Redis host itself is Redis. Okay, you can see if you don't mention environment as Redis host, and by default it is taking Redis, so that is already given as Redis. Okay, so will not face any problem. Now I need to push this. I need to pull to cd user docker build -t user v1 dot. So let me check once again the Docker file of user. Is everything fine? Yeah, everything is fine. Okay, building the image. Now I need to configure Docker run -d -name user and then network, something like this. Okay, so instead of this every time, what is the problem if you run manually? Okay, first thing, manual Docker run commands. What are the disadvantages? Okay, you have to give all options through the command line. Okay, so this is one thing we are doing. And dependency containers should run first. Okay, now if you want to start and stop, so start one by one and stop one by one. Okay, so this is what we are doing, starting first in a sequence site, that is MongoDB, and then catalog, and then web, and maybe user. So like this, we have to start one by one. And while removing also, you need to stop one by one all at a time. So addressing these disadvantages, we have something called Docker Compose. Okay. So Docker Compose is a simple command line tool. So what it does is start, stop, and rebuild at a time. Okay. And then so it will use a YAML file to configure the services. You can start and stop at a time. You can view the status while starting and stopping. And so this one, they will discuss this in the Kubernetes layer. And you can mention all options here. They didn't give us everything. Okay, so basically So every time it is painful for me to give all options and run manually one by one. Instead of that, you can have Docker Compose. Okay, the Docker Compose. You need to install Docker Compose and you can define the services here and you can have depends on, just like in Terraform depends on. So Docker then understand the dependent services and it will create first. Okay. So now let us see this. This is very simple. Sample Docker Compose file. First, I need to install Docker Compose. Install Docker Compose CentOS 8. Okay. First, let us install Docker Compose. Okay, so this is the command. Need sudo access. Okay, and then just give this permission. Sudo. Okay, so now Docker Compose is installed. So it is very simple. You no need to worry about that much. Okay, let me take some sample from the internet. Anything. Okay, give me some any folder. Okay, it is like this. Services, you have to mention your services one by one. And let me take something more. So there is a version actually, but it is not mandatory. So let me keep it as Docker compose.yaml. If generally this is the file name we use, and I'm mentioning services. That's it. What is my service? MongoDB, for example. Just mention as MongoDB, and then a tab space. So image. Obviously, you are giving the image, right? Just compare this with this one. Docker run -d and hyphen name, that is MongoDB, and then hyphen network, so that is RoboShop, and then MongoDB :v1. Yes, this is the command, right? What is this? This is image. So you have to mention here as image MongoDB :v1. And there is a thing called container name. You can just mention it as MongoDB. And then what else? Network. So since all services using same network, so there is a section called network here, networking in Compose. Okay, so there is a section called network like this. So you will mention networks and RoboShop. Driver is bridge. So it will create the network automatically. Okay, that's it. And then, so here this network will be created, and you need to mention this here as networks RoboShop. Okay, so this will create the network, and so this MongoDB is we are mentioning the image name, and networking information, everything. Similarly, catalog. Image is catalog :v1, and container name is catalog and networks RoboShop. Okay, so this is that much simple. Similarly, web image, web colon v1, and container name is web, networks is RoboShop. But it has something extra, that is ports. Okay, ports we need to mention 80:8. That's it. Okay, but you can define the dependency here. Catalog is always depends on MongoDB, right? Similarly, web is always depends on web, always depends on catalog as well as user. So now I need to mention user definition also. Before that, Redis image is Redis, container name is Redis, again networks is RoboShop. Okay, and now user image we built, so user colon v1, and container name is user, and then networks is RoboShop, and what else depends on, so user always depends on MongoDB and Redis, right? So now what I do, I will remove all the running containers, docker rm -f, docker ps -a -q. So now what I do is git pull. I need to push first. Okay. So here git pull. So let me remove the network also. So Docker Compose can create the network automatically. Docker network remove RoboShop. Okay, but make sure you have all the images. I have user, catalog, MongoDB, web, everything is available. Okay, Redis, even it is not available. So this one can pull because I am using the image from the internet. Now, what is the command? Command here is Docker compose. By default, it will take docker-compose.yaml up. I want to take all the containers into detached mode. Okay, that is -d. If you give here, so this -d will work for all services you mentioned inside. Okay. Now you can see what happened. First, MongoDB is done. Next, Redis. Next, user, catalog, web. All the containers are running. Okay, if you have this file available, you don't need to run all the time manually docker run commands. You can see all the containers are up and running. Now let us just check it. User module. Just creating Siva. Something. So it is getting an error. Can someone guess what is the error? Can someone get what is the error? Please type in the chat. But this is not zip, but fine. What is the error? Please guess in the chat. So the error is because the request will go as API/API/user, right? So, but this I haven't configured in ProboShop.configuration. So I need to mention again here this one. API/user. If any request you get this, send that to user container. That's it. So when something is changed, you have to obviously rebuild the image. CD web docker build -t web v1 dot. Okay, I rebuilt. Now you can just mention docker compose up -d. It will automatically recreate. You can see it will detect the image is changed. So I'm recreating it. Now let us just check this. Register. So now it is working. Okay. So now let us configure our cart also exactly the same way. Extracting. And take package.json and just go to DevOps, AWS, repos, create one folder here that is cart, and inside you can paste. Okay. So the cart, what are the dependencies? Cart is dependent on Redis, it is already running. Cart is dependent on catalog, it is already running. So let us just configure Docker file exactly same. Okay. Package.json, and this is not required. Okay. Because cart is not connecting to MongoDB, it's connecting to Redis and catalog. So this is fine. That's it. Nothing, no other changes. Everything is same. Now push and pull cd cart and then docker build -t cart v1 dot. So this cart image will be built. Now I can just mention this in Docker Compose as cart image is cart v1 and container name is cart. Networks, you can mention RoboShop, and then this depends on Redis, and then catalog. Right? I'm just mentioning like this. Now I will push. So this is still installing. Maybe the image, maybe the low memory. Okay, let me just check that. The memory is very less. That is the problem. So in this case, what I do here, I have to stop the instance and I can increase the instance to P3 medium, and then I can increase the hard disk memory also, but that takes some time. So instead of that, what I'm doing here is I will simply launch another instance. When we are learning Docker, it is fine, but when you are configuring project, T2.micro is not enough. Just launching T3.medium and just leave the memory as 30 GB, because 10 GB is not sufficient. Our images memories are getting increased. Generally, I can reboot. Oh shit, I didn't select T3.medium. Let me stop. So this is old instance. Let us check. Stop. I will change the instance to T3 medium. Three medium. Like so still not able to start. So this is old instance. Okay. If you see TF-HT, memory is fine. Docker images, it is fine. V-M, RAM is 271 MB. So it is okay. Let me just use this old instance only. cd cart docker build -t cart v1 dot. Okay, cart is built. So when it is small instances, sometimes the cache will become more. So you have to occasionally restart the instances. But if you take bigger instances, there will be no problem. But it's fine. You can start with t2.micro only, just to save some cost. Docker compose and now sorry, dp git pull. So we change Docker compose, right? And similarly, you have to change in RoboShop config also. Need to have API/cart and then cart :8080 and then you can mention the web is dependent on cart as well. Okay, push and git pull. So I changed the web definition. Now I need to rebuild the image. Docker build -t web v1 dot. Now you can do Docker compose up -t. Now you can see only since I restarted, it is creating everything. Okay. Now let us go and check. The cart is working. Okay, now shipping and payment. For shipping and payment, we need first MySQL. So I'm just creating MySQL folder and MySQL. Anyhow, we are getting it from the internet, but we need to load the shipping data. So we have in shipping, we have this one, shipping.sql. That is the country information, everything. So first let me download that shipping so that we can get the code. Shipping is little different. Okay. So let me get this RoboShop GitHub. So here you can see there will be a MySQL and Docker file is there. Just let me get this Docker file. Because this is not an application, this is just database. Okay, it is getting MySQL 5.7. You don't need this also. And then they setting some environment variables. That is fine. And This is not required. This is also not required. Just copying the scripts. So you should have some scripts folder here into same Docker entry point init DB, so that whatever scripts you mention, that will be loaded. Okay, you can see ratings, everything. So this one we need. Can I get this? Inside shipping. Let me open. Schema. There is shipping.sql. Let me keep that here. Let us see this will work or not. Oops. Suppose. So this is almost 63 MB because all countries and then all cities information. So, yeah, but definitely MySQL needs a lot of memory. I doubt so this instance will work or not. Let us just try. Okay. Just using the MySQL open source image, setting some environment variables, and then copying the scripts into the. Let me check this MySQL image. Where is our Docker Hub? Just check MySQL image. And then here there will be information. It can have .sql or .sql.cz. So whatever it is there, it will automatically load. So that is not a problem. Okay, we can just keep that. Now push. Okay, that is pushed. Now let us pull here. cd mysql docker build -t mysql:v1 dot. Okay, so MySQL image is built. Docker images, MySQL image is built. Now let us try to mention this in Docker file. That is MySQL. Image is MySQL colon v1. Container name is MySQL. And then networks, RoboShop. And there is no dependency. That's it. Okay. Now push and pull. Try to run Docker compose up -. So it only created MySQL because everything else is up to date. So now it says MySQL is running. Let us check. Docker. Oh, stuck. That is the problem. Large images and containers. So let me pick up this T3 meeting. So now I need to again do it from the scratch. What is it? Install the Docker. First install the Docker. Sudo bash. So after installing Docker, I need to again clone our RoboShop, and I need to build the images and I need to run the Docker command. Okay. So it will take some time, anyhow, 2-3 minutes. So within that time, let us take a break of 5 minutes. We'll come back at 8:02. Okay. So just exit. Login. Okay. Just clone our RoboShop Docker. It clone. RoboShop Docker. Now I need to build the images one by one. Instead of that, you will just run a command. You know this, right? This one. For I in something like this. So I'm just doing this simple for loop for I in. Generally, what you get ls hyphen t start. I should only get the directories. Ls hyphen t star slash. I think directories here, but I don't want this hash slash. Sorry. Okay. So for loop and then to cd dollar I docker build hyphen t dollar I colon v1 and then dot cd. Just I'm building all images at a time. got some else. That is because we are getting compose also. Sorry. We are getting here. If I don't give slash, we are getting proper compose also. If I give slash, the problem is, so this will come with the image. Cut hyphen key slash F1. Okay, so this one I can give for I in CD to CD $I Docker build hyphen T $I colon V1 dot CD slash and then done. Okay. So now this should get success. Okay, all images are in built. Then now if you see Docker images, we have all the images available. Just copy this. Now, Docker compose up hyphen D. Did I mention Docker compose for MySQL? Yes, I mentioned. Docker compose also need to be installed. I can mention this inside our Docker install script. Send to this 8. Sudo it's two commands can install Docker compose. Okay. Containers are created. Docker ps Docker exec hyphen it MySQL and then bash. Just logging into MySQL, then checking MySQL to show databases. Okay, cities information is loaded. That is fine. So now it is done. MySQL is done. Now we need shipping. So shipping is little bit complex since it's a Java project. So we already got shipping, right? So let me copy src in form.xml. AWS and DevOps, shop, shopper, shipping. The shipping is Java project. So let us see the difference. I need to get the Docker file. Let me just take the reference of this one. This. So this is called multi-stage build. Okay, you can see here what is going on. We have two from statements. This is one and this is one. Actually, these are like two Docker files. Okay, so we'll discuss this maybe in tomorrow's session. Once we complete this, what is multi-stage build? This is multi-stage build. Why we need multi-stage build for Java projects? So like Node.js, how we are on node server.js. Here directly we are running code. Generally Java is heavy programming language. Not like Python, Node.js. It's not simple. Compared to any other programming languages, it is heavy programming language with its own advantages. So that is why it is mostly used in enterprise projects. Generally in Java, so there is JDK and JR. So JDK equal to compiler plus JR, Java runtime environment. Okay, JR. So JDK is more. So normal codes like Python, Node.js, React.js, you can directly run the code. But Java is a little bit different. To write the code, you need to compile it first. So this will create bytecode, general bytecode, and run bytecode. This will give us a little bit speed actually compared to any other programming languages. So for compilation purpose, you need JDK because we need compiler, Java development kit. But running purpose, we don't need JDK, we just need JRE. Okay. So just understand this behavior of Java. So Java code is not like Python or Node.js. First, it should be compiled. That will give us bytecode. Then you need to run the bytecode. Okay. For compilation purpose, you need JDK. So JDK is compiler plus JRE. So obviously, JDK memory is more than JRE. Okay, that's it. So now here you can see we are installing Maven because we use Maven dependency resolution as well as package. So this will automatically compile. Okay. So here we have some extra packages like Maven that will give us JDK environment. Okay. So generally Maven will give JDK kind of environment. Here we compile and package. Okay. So this is packing the application. That is nothing but bytecode. So this will give us .jar file. So .jar, Java archive file is the bytecode. So in this stage, we are getting the bytecode. Okay. Here, you can use JDK or JRE, not a problem. You can use JRE also. Here, I am copying the bytecode from this. You can see the shipping.jar. I'm copying it and then I am running this. Okay. So I will get full clarity maybe tomorrow because tomorrow we will discuss our multi-stage builds as part of best practices. Just for now, just understand this concept. Okay, why Java is different with compiler and bytecode, and then let us proceed with this. In the first stage, I am installing many packages, Maven, and Maven is a very heavy software with generally Java by default installed. And then we are taking the package. Once we get the package, we don't need this. So I'm just copying the package here. You can see from build, copying from this one build, and then copying here and running this. So multi-stage builds are used to reduce the memory and to remove the unnecessary installations. You will get full clarity tomorrow. For now, let us proceed. So it is connecting to MySQL. DB host is MySQL, and it has dependency on cart also. Cart 8080 running is obviously running the same name and port. But here, let me check the username and password of our MySQL, because here what we are using inside MySQL, we are setting up the password as roboshop1 at the rate 1. But here what we set up, the user is shipping and the password is secret. User is shipping and password is secret. But here we set the password as roboshop at the rate 1 in our shipping code. Let me just search this. Go to our shipping. So you need to understand this, okay? You need to understand the code. Don't worry about that. Part city repository. Password is mentioned here. Okay. Here it is mentioned as shipping roboshop at the rate 1. So instead of changing in the code, we can change it in our here. So user is shipping and roboshop 1. I will change it here. Okay. So that you will not worry about changing the Java code. So I changed this. So I need to rebuild. Git pull cd mysql docker build -t mysql v1 dot. So that is done. And then, yeah, cd space docker compose. So let us complete our shipping also. Let me mention here shipping image shipping v1 container name is shipping networks roboshop. Depends on cart and then MySQL. That's it, right? Cart, MySQL. Yeah, those two. Okay, done. So before that, I need to create shipping image. Docker build Docker trail -t shipping v1 dot. The Docker file here for shipping is nothing but I'm installing Maven because I need Maven, because Maven package is the one that is creating our uh, jar file. Okay, so the same we did it in while installing manually also. The same we did it. You can see Maven clean package. So that's what I'm doing here. But for that, I need this Maven package. There is some problem. -y. Shit. First I need to push. I have to get -y installed. So installing Maven and Debian is getting us a problem. Okay. Why don't we install? Why don't we use directly Maven image? So let me directly use Maven image from Maven. Okay. Some problem. Let us not worry about that. Full access denied. Repository does not exist or may require. Building is done. This, oh yeah, I need to mention build, right? So it's this one to mention as build. Okay, because it is copying from this one. It full. Okay, so this is done. Shipping is done. Now let us run Docker compose up -d. So everything is up to date. MySQL is created and shipping is created. And one more thing we forgot, that is web configuration here. I need to add shipping. Shipping 8080. And I change something, need to push and need to pull, rebuild the Docker, build -t web v1. Okay, now Docker compose up -t will recreate the web. Okay, now let us try to access this. Login. Login is done. Let us add something. Add to cart. Cart is working. Checkout. Yeah, shipping is also working. Okay, now it's payment. Payment needs RabbitMQ. So RabbitMQ don't have any extra configuration with us. Let's see. RabbitMQ don't have. Okay, we have a user, RoboShop, and then RoboShop 123. Let me see the RabbitMQ image. RabbitMQ. This is the official image. Just check whether they have any user. Setting default user and password. So you can have something, these environment variables. So now what I'm going to do, I will create RabbitMQ folder, RabbitMQ, and one Docker file. So you can just refer this RabbitMQ here. User web shipping, rating, payment, MySQL, catalog. There is no RabbitMQ. Okay, inside payment, maybe they have mentioned it. So you can take this image, you can just mention it as RabbitMQ. We'll take the latest image. So from RabbitMQ. So this is the image I want. So I don't need any extra things actually, except username and password. So that's what we are doing, installing and setting the username and password. So what RabbitMQ documentation is telling us, you mention this environment variable, env equal to, so what is the one we are using? Now 4, RoboShop and RoboShop 123. RoboShop, and again RabbitMQ default password. RoboShop 123. So now this will pull the RabbitMQ image and it will set up this user, right? So we need to mention this here as well. RabbitMQ. Name is RabbitMQ. Or else I can directly mention here environment variables. I can directly mention here. So what they are doing here, while running the image, they are mentioning the environment variables directly. So for that purpose, in Docker Compose, we will have some option environment variables. Okay, can have an option environment. So environment. So instead of maintaining Docker file and folder again, I can directly do this. List of environment variables. Just mention this. So that you no need to maintain again another folder. I will delete this. Directly I mentioned getting the RabbitMQ image, and while running, I'm asking Docker to set up this environment. Okay, that's it. Git pull Docker Compose up hyphen. Docker PS. The problem is I didn't set up the network container name. RabbitMQ networks RoboShop. So, but before that, let us set up the payment also. Payment. Let me get our payment code. Extract. Copy this. Oops, push, repos, and RoboShop Docker payment. I'll copy the code here. Okay, so we can just get the payment related Docker file from here. This is simple. Docker file. So you can see I'm just getting one base OS. This is exposing and setting up the root. Don't require this. I'm not using that. And we are installing the requirements pip install and copying this and copying our code dot payment files and payment.ini and then running it finally. Okay. That's it. RabbitMQ is using the guest password. Our code is using this guest and then guest. So this payment is dependent on cart, user, and RabbitMQ. three things. So that is why you can see in payment.py, cart host, it is cart. Cart port is 8080. User host is user. Port is 8080. So this is all fine. This is no problem. We have the same values, but I'm just thinking this RabbitMQ. I just change it to the different one, the default. Let me just check where this match is. Is that payment product service? So it is mentioned here. It is by default using guest and guest. I can set up the environment variables here, env amqp underscore user. What is our amqp underscore user? Roboshop and Roboshop 123. AMQP pass equal to Roboshop 123. Okay. So what happens here? First, it will check for this environment AMQP user, AMQP password. If it is not defined, then it will consider these values. But I'm already defining here Roboshop and Roboshop 123. It pull CD payment Docker build. We will complete and then close this payment colon v1 dot. So this is building Python. So meantime, let us configure our Docker Compose. This is payment image payment colon v1 container name is payment networks is Roboshop and depends on cart user RabbitMQ. Okay, ultimately, our web is dependent on everything like shipping, payment. Okay, Python is building. Okay. Python is built. Now git pull and then Docker Compose. Compose up -t. Okay, so everything is done. I forgot one more thing. In our web configuration, we need to have payment also. So push pull rebuild the web Docker build -t web colon v1 dot and then Docker Compose up -t that will recreate web Now it is done. We log in. Go to cart, checkout. Calculate. Okay, now we got an error. Let's see. This the error. It's not working this browser. Let me take another browser. Inspect. Take the network. Log in. And go to cart, checkout, Australia, Sydney, confirm, pay now. Now we get an error here. Payment error. So something internal server error. Now Docker logs web. So payment got an error. Let us check the payment. So payment for Siva, we got that here. Object has no attribute. There is an error input. Just this log underscore KV. Check. So did we miss something in payment? Users, exactly all these things we have. Let's see this. Python. This log underscore KV here. Payment dot pay, right? This is purely development error. To fix some code. It continues. Professional. Okay, so this error, I will fix this. You can stop it here. I'll just extend it. Any questions? So tomorrow we will complete this and then we will proceed for best practices. So now you know how to create Docker files, how to build, how to configure a project using Docker containers, how to set up the network. And tomorrow we will discuss the volumes, and then we will continue with best practices and disadvantages of Docker. Why should we use Kubernetes instead of Docker? Okay. Any questions? Any questions? No questions? Yes, Sattar. Hello.
Hello, Siva.
Yes.
Yeah, good morning. Like I am comparing this Docker and Ansible. Okay, like in Ansible, we are writing playbooks for deploying an application.
Okay.
Like a difference between this configuration manager and this containerization. Any other thing like you want to add in this thing?
What you want me to add?
No, no. Like I am saying, there is no much difference between application deployment. Like I am finding w- less less resources we can utilize it Docker. Like,
Yeah,
that's it.
correct. That's the only difference between VM and Docker. If less
Yeah,
memory, you can.
instead of Ansible, we can use Docker, right, for deploying application. My doubt.
Yes, if you use Docker, no need to use Ansible for application. Okay.
Okay.
But still, this Docker, someone like Linux administrators, they use Ansible. We need VMs to run the Docker. So you need VM, right, to install Docker.
Yeah, right.
So those Linux administrators, we don't need to use Ansible for the application deployment. Okay, so that can be removed. As you said, that is correct. We can
Okay.
only use Docker for application deployments. Yeah, that's correct.
Is there any difference between Docker and Ansible? You want to add that?
Functionality wise, there is no difference.
Okay.
Ansible is used for VM. Docker is used within the VM.
Okay.
Okay. So
Yeah.
now I'm installing Docker through shell script, right?
Hmm.
Now what you can do, you can create the instance, you can install Docker through Ansible, you can install Docker Compose through Ansible, and every server, I'm just taking it as granted, right?
Hmm.
But every server, there is something called Center for Internet Security. So generally, when you take laptop, what you do, you will install antivirus, and you will take care of, you will do something to make your laptop secure, like harden the laptop. In our companies, we use our company laptop, right?
Yeah.
So what they do, so they will not allow to browse Facebook or some other sites, and they will continuously monitor your traffic. If you do something wrong, you will get an alert. So that is the laptop hardening. Similarly, there is server hardening. Whatever the server you use, either Docker or Kubernetes, the underlying server should be hardened. Okay. So for that purpose, you can still use Ansible. So we are using Docker for application deployments, but still we need some servers, right?
Yeah.
Who will configure those servers? How can you configure? That is still through the Ansible only. Okay.
Sure.
So Ansible is for configuration management of the server. Docker is for application.
Okay.
So Ansible, because of its advantage, we were using it for VM deployments also. But once you move to the containers, you don't need Ansible for application deployments, but still you need Ansible for configuration management.
Okay.
Got it?
Thank you.
You got it, right?
Yeah. Yes, Siva. Thank you.
Any other questions? Sriram,
Yes, sir. Good morning.
good morning.
Yesterday we didn't get the images, right? What are the changes you made today in that catalog?
That's what I said. Catalog, I mentioned. So catalog here, what I mentioned yesterday in MongoDB while loading the data. So this one I took from the internet. The names here and the images inside web is different. Okay, yesterday. So I copied from our code only. I downloaded our web, right? So I copied catalog.js from our code. So it was in sync. When you are practicing, you just copy the code from our repository. Okay, copy code from our repository. That's it. If no other questions, we can end the session. Okay. Have a nice day. See you tomorrow. Bye.